Hi, welcome to the channel Coder's Arc, where we unravel the world of coding and architecture together. In this video, I'm going to show you how to build agents in the Langchain framework. In the past, I've done some videos on how to build agents in AWS using Bedrock and how to build the agents in Salesforce using Agentforce. But Langchain framework is an open source framework which helps you build agents in a cloud-agnostic manner. And once built, they can be deployed across any cloud like GCP, Azure, or AWS. In this video, I will cover key concepts like tools management, how the agents iterate through the framework to communicate with the large language model, how the memory management is done, and I will explain these core concepts in such a way that you will never forget them. Because I've seen there is a lot of confusion. Most people understand how agents work, but they don't truly understand how the interaction works with the LLM. So hopefully by the end of this video, you will understand the Langchain framework. In the next video, I will also talk about the LangGraph, but in this video, I'm just going to introduce you to the core concepts of Langchain framework. So let's dive right into it. To understand the core concepts of the Langchain agent control flow, let's take a closer look at this picture. Usually, the user submits their query in the form of natural language query to the Langchain framework. The Langchain framework has what it calls an agent executor, which is responsible for communicating with the large language models. Its responsibility is to manage the memory, manage the context, and create the prompt in such a manner that the large language model is positioned to answer the question. Usually, the LLM is not able to answer the question in one go. It has to think through the problem, and usually if the problem is complex, it needs to break down the problem in several steps and iterate through each step and try to answer that question using the tools that are available. Now, the tools that are available could be either the network tools, could be the APIs, could be some structured or unstructured storage, but these are the tools that are available by the framework to the LLM. So when the prompt is constructed by the agent executor, it gives not only the question that the user is asking, but also it defines how the LLM has to think through the problem, and also it defines the definitions of metadata that's available in the external tools. And it gives all of that information to the large language model and iterates through this process so that it can get the final answer to the user. Usually every time the large language model thinks through the problem and gives a response in an iteration, that is processed by the response parser, and this loop iterates till the final answer is achieved. Now, the framework is also responsible for defining certain stop conditions, like whether the final answer is detected by the LLM or there are maximum number of iterations reached, because LLM can go through unlimited number of iterations. So the framework is responsible for defining what is the maximum number of iterations within which the response should be received. And also it can define certain stop conditions, like whether the error threshold is exceeded. So as you can see, the framework is just an orchestrator. The Langchain framework is just an orchestrator. The brains behind actually thinking through the problem, reasoning through the problem, responding and giving responses through each iteration, that is the large language model. The LLM is the brain and the Langchain framework is the muscle. That's how you can think through this. So let's look into how the prompt engineering works in Langchain. I want to briefly cover the concept of prompt engineering in Langchain because it's very important to understand how the React agent, which is the reasoning and acting agent, interacts with the large language models. Because it's not a simple question that you're asking to the LLM. The framework, the Langchain framework, is responsible for structuring the prompt in such a manner that the LLM is able to think through the problem, take actions on the problem, observe its action to the problem, and then iterate through that. So that has to be provided to the LLM in a structured format. Then there is the tool descriptions. So these are unstructured definitions of the tools that are available to the large language models. Imagine if you have some APIs the best ways to define the tool description is using the Swagger file, which contains the information on the endpoints, the summaries of the methods that are available in the APIs, and the endpoint definitions as well as the parameter definitions. Then it's optional, but some agents are able to provide a few short examples. And finally, the context management. The framework is the one that's responsible for managing, maintaining, and passing the relevant context information from the previous steps. I want to briefly touch on the memory management in the Langchain framework as well. Usually, the memory for all the context is managed through the agentic framework, in this case, Langchain, not the responsibility of the large language model. This is a critical feature that enables the multi-step reasoning. Some of the primary memory classes that are available through the Langchain framework are conversation buffer memory, which is the simplest form that stores all of the messages in sequence. Usually it gets into trouble when the window context size is smaller than the conversation size. Then you have the conversation buffer window memory, which only keeps the last k interactions because it's buffered. Then you have the conversation summary memory, which summarizes the older conversations to save the token space. It does not retain the entire older conversation. And usually it uses the large language models to create these summaries through individual iterations. And finally, you have the conversation token buffer memory, which tracks the token count and drops the older messages when exceeding a limit. This is also configurable through a max token limit parameter. Now, if you do not specify the memory in the Langchain framework while you're creating the agent executor class, then it's just going to use the default memory, which only keeps the current question and the current context for the current problem. So for example, if you ask a complex problem in one question, the agent and if it breaks that question into several smaller sub-problems, it will retain that context. But if you ask a next question, it will not remember the context from the previous question. So important to use the right memory class. We will see that when we look at the tutorial. So now we are ready to take a look at the POC that will clearly illustrate how the Langchain framework works. In this example, I will show you first how I created a Langchain agent using a container. In the code, I will clearly show you how the React agent is constructed, how it has the tools exposed to it. I have created some local math tools, which are nothing but some Python functions, and I have some local definitions for those functions. And I've also created some API tools that are accessible through the Swagger definitions. Now these APIs are hosted in AWS and sitting behind an Amazon API gateway, and these are just Lambda functions. And finally, I will deploy this container in Google's container registry because I want to illustrate the Langchain framework can be deployed across different clouds. So in this particular example, I will deploy the container in the Google's container registry, and then I will make that container available to the Google Cloud Run service. I will expose the endpoints to the end user over HTTPS so that the end users can pass the queries like complex questions, and we will see that in the example. And then the large language model, in this case, we are using the Amazon Bedrock, but it could be OpenAI GPT-4 or any other large language model of your choosing. And finally, when the user asks the question, the agentic framework kicks in and uses the reasoning and acting capabilities to construct a proper prompt for the LLM and manages the iterations till the final answer is achieved. So we will see all of that in the demo. So now I'm in my code example that I created to show you how the Langchain agents work. So I have a method that I have defined. This code is written in Python, but there is a method called define get agent. So let me expand that method. Let's skip over to the most important part of this method, which is construction of the agent. So this highlighted thing is the most important part, where first we create the prompt that is needed to interact with the large language model. So let's skip over to that portion. If you look at the prompt that I created, so I told this agent, you are a helpful assistant that uses the tools to answer the question. I have provided the tools definition as a custom dynamic variable, and I have defined some few short examples on how to parse through the tools. Then I have given the definition of how the question should be understood, thought through, and how the LLM should take an action, observe its action, using this thought action input observation pattern and repeat through it multiple times. And I'm also explicitly telling the LLM that if you do not know the final answer, respond explicitly that this is not the final answer. But if you know the final answer, then explicitly say that this is the final answer. And then I ask the large language model to begin. Again, this is all handwritten. If you want to play around with this, feel free to, because this is the most important part. Usually you want to construct a proper prompt for the large language model to think through the problem. This is the key. This is where most agents falter if you do not clearly specify the instructions. So remember, prompt engineering is extremely important when you're communicating through the agents with the large language models. So let me go back to that class now. And here, so we looked at what the prompt is. Let's look at the LLM. LLM in my case, I can iterate over there. It's coming from the getLLM method. And if you look at the getLLM method, it shows that I'm using the Bedrock Anthropic agent for this one. So let's go back. And finally, let's look at what's the other thing that's needed in the agent. It's the tools. So this is the very important concept, tools, right? So you will be wondering how the tools definitions is made available while creating the agent. So let's look at that. So tools are mathematical tools plus the API tools. So let's dive right into this. Let's look at the mathematical tools that are available. So I created some local tools. These are nothing but simple Python methods that I created locally, like add tool, and then I've given the description add two integers, and I'm explicitly saying that if these two should be numbers, they could be separated by a comma or a space, and when you receive those two numbers, add them. Similarly, I have a subtract tool, multiply tool, and I have given explicit description so that when large language model encounters these tools, it's able to know how to use these tools to solve the problem. Now, I also created an API tool. Basically, what I am doing over here is I am parsing the Swagger file that was provided. So I have already created an API, and I'm parsing that Swagger file that has the definition of those endpoints and making it available. I will very quickly show the code that I wrote for this API. If you look at the methods available over here, I've created 4 controllers. One is a financial impact controller, one is a health hazard evaluation controller, another is a quality assessment controller, and the other one is a risk impact controller. If you don't really need to know what these controller or these APIs are doing. I think the only thing you really need to know is that I have explicitly created a Swagger file. So if you look, I have explicitly specified the definitions of these endpoints. I'm specifying what each endpoint is doing, what each parameter is doing, and I have put some English letter description over here. I think that's the most important thing, that you have to define what the APIs are doing so that when the Swagger file is constructed, it has a lot of English language, natural language definition of what these APIs are doing. This is extremely beneficial when you pass these tools to the large language models. Now I want to quickly show you how once I compile my code, I'm able to deploy my Python code, my Langchain framework code as a container in my local Docker desktop. So as you can see now, I'm serving that through a container on the local 8000 port. So let's use the postman to make that call. So let me expand this. I have a health check endpoint locally. So let me first see if my agent is healthy. Yes, my agent is healthy. So now let me make a call. So basically I have mathematical tool. So I have an endpoint called API/query, and I will call that endpoint with a human natural language question. Can you tell what is 9 multiplied by 99? So let's call it. So the large language model and agentic framework working together give me a response saying that 9 multiplied by 99 is 891. And if you want to look at how the LLM reasons through that problem, we can see that in the logs. So I know this is a lot to read, but essentially whenever the run is executed, it gives a pretty detailed instruction on, or pretty detailed description on how the large language model broke down that problem. So I'm not going to show you this, but basically you can parse through the logic or through these logs to figure out what's that logic that LLM and the agentic framework use to get to the final answer. Essentially it's the same thing that I was showing in the previous slides around reasoning and acting and observing and doing iterations till the final answer is achieved. Now let me ask a question about a network boundary, right? So usually a question that is not available through the local tools, but through the tools that are deployed on the APIs. So let's see. Can you tell me what is the quality impact for investigation with ID 9? So now this is not one of the mathematical tools, right? And if the large language model does not have a tool, it will give some kind of a hallucinated response, or it will say, I do not know the response. But in this case, since we've already provided the Swagger file definition, which contains a lot of English natural language definitions of the endpoints and the parameter definitions, it will use that to answer this question. So let's ask this question. And again, I mean, you can look at the logs to see how the LLM reasons through those questions, but essentially it gives a response. You can read through this response, but essentially the response is that the quality assessment for recall with investigation ID was found, and it gives a lot of details, and it says that the status is non-compliant, which is assessed by the quality control team. So it is an answer that it thought through based on the API Swagger file definitions. Finally, the last thing I want to show you is that once this local container is tested and you have used Postman to test the functionality of the container, that this is a Langchain agent, right? So this is the beauty of the Langchain agents. They are cloud agnostic. So you can take this container and deploy it on any cloud. You don't have to use Bedrock agentic framework or Azure's agentic framework or GCP's agentic cloud framework. You can literally take this container and deploy it on the Google Cloud or any other cloud. So here I am on GCP. So let's go into the Google Container Registry. So let me go there. And I've already deployed that container image over here. So let's look at it. I created a repo and I already posted that container over here. It's called Langchain Agent. And then finally I can launch this container using the Google Cloud Run. So let me go into the Google Cloud Run. You can see that the container is running successfully. So if I click over here, I can get the endpoint. So this is the crucial endpoint. So now all my queries to this Langchain agent would be on this API, this endpoint, and I can test it similar to how I tested the local container. So I already have that. I have a get health check that is on the endpoint that we received. I also have GCP mathematical endpoint, basically the same endpoint, but it's now deployed on the cloud. So I get this similar answer. As you can see, it's thinking through it. It gave a response successfully, and similarly it will give response to the API based queries which were exposed through the Swagger file definitions. So in this video I showed you how the Langchain framework works and interacts with the large language model. I've also shown you how to test the LLMs locally using the Docker desktop, and finally how, because these Langchain agents are cloud agnostic, they can be deployed on any cloud. In this video I showed you GCP, but it can be deployed on AWS using Fargate or EKS, and similarly in Azure using the Kubernetes managed service. So hopefully you found the value in this content useful, and if you did, please hit the subscribe and like button, and I will talk to you in the next video where I will introduce you to the LangGraph concepts. Thanks everyone.